Welcome. We're PiazzaGate, and we're doing a project about COVID misinformation on Twitter. Recently, we've seen a huge surge in misinformation about COVID-19 and its vaccine. And really, this is a continuation of a long history of misinformation spreading on online social platforms like Facebook and Twitter. We're hoping that by investigating how COVID-19 misinformation spreads, we can understand patterns about how misinformation spreads online in general to better inform policy to counteract it. There are popular conceptions about how certain demographic groups tend to spread more misinformation and want to verify these claims with statistical data. Finally, you want to understand how misinformation reacts to developments about the topic in the real world. In this case, we want to understand how COVID-19 misinformation relates to changes in the case count and vaccination rates. To do this, we collected a number of different data sets. We have a data set of COVID-19 related tweets geotagged to the county level. And to supplement that, we also collected county level COVID-19 cases and vaccination data, as well as demographic and voting information. We filtered for misinformation tweets using hashtags and Boolean string matching, and we translated non-English tweets into English, and we finally dropped rows of null values. We did a number of different training test splits for our exploratory and confirmatory analyses. We had to split our data randomly for our demographic analysis, but for our analysis about COVID-19 and vaccination rates, we did a time series split because we are doing that analysis along the time dimension. Finally, we also created a data set of unfiltered regular COVID-19 tweets to verify that any interesting patterns we find about misinformation tweets are unique to misinformation themselves, but not a pattern that we can see in regular COVID-19 tweets. So taking a look at our data, we find that the number of tweets per state are heavily distributed in the most populous states. But when we look at a different metric, the tweet rate, which is defined as the number of tweets per million people per state, the distribution looks much more different and it's much more uniform.
One of the questions we wanted to answer during our exploratory analysis was whether there are correlations between the rate of misinformation tweets per county and demographic county statistics. To answer this question, we ran simple regressions for each feature of our demographic data, and to get a stronger trend, we removed the counties with a tweet rate of 0. Here we have 6 graphs of regressions on the features that exhibited the most interesting trends. We were most interested in the correlation between voting pattern and tweet rate. We found that percent votes Democrat is negatively correlated with tweet rate, whereas percent votes Republican is positively correlated with tweet rate. We found similar trends for mean retweet rate per county. In the next phase of our analysis, we were interested in confirming whether the opposing trends between voting pattern and tweet rate exist, and we'll control for trends involving income and education.
For our second analysis question, we looked into potential correlations between the number of misinformation tweets and the number of COVID cases, deaths, and vaccinations over time. To do this, we drew a multiple line plot on different scales. We noticed that the plot's highs and lows were generally around the same time period for each of tweets, cases, and deaths, suggesting that there might be a positive correlation between these 3 features. We also saw that cases, deaths, and tweets seemed to decrease when vaccinations started rising, suggesting a potential negative correlation between vaccinations and tweets.
Our first hypothesis is that Democratic counties tend to proliferate less misinformation, and Republican counties tend to proliferate more when accounting for per capita income and education level as other relevant indicators. Here, the proliferation of misinformation is quantified by tweet rate and mean retweets per county. Our second hypothesis is that the number of vaccinations over time negatively impacts the number of cases over time, but also positively impacts the number of misinformation tweets, and that the number of cases over time positively impacts the number of misinformation tweets. The null hypothesis for both alternative hypotheses is that these trends do not exist.
When running confirmatory analysis for demographic trends with mean retweet count, we didn't see significant p-values, so we can't draw conclusions about relationships between political affiliation and retweet count. So I'll begin with test results investigating regressions between demographic data and tweet rate. When controlling for income, the political affiliation coefficients match our expectation, where Republican-leaning counties are correlated with a positive trend and Democratic-leaning counties have a negative trend. These have significant p-values of less than 0.05. When controlling for both income and education, the political affiliation trends maintain their sign and significance, So we confidently reject the null hypothesis that political affiliation and misinformation tweet rate have no relationship. Additionally, in the second test, income and education are statistically significant indicators with p-values less than 0.05, where education has a negative impact, which is expected because more educated people tend to spread less misinformation, and income has a strong positive impact. We can't explain the second finding, but we find it interesting and a promising area of future research. Now I'll discuss results for the unfiltered dataset. When controlling for income, the political affiliation coefficients are no longer significant. And when controlling for income and education, only the Republican coefficient remains significant, but the coefficient's very small and has a flipped sign. So we support our hypothesis about the relationships between political affiliation and misinformation tweet rate, because the relationships are present for misinformation tweets, but not for general COVID tweets. We also found it interesting that income is a significant indicator of general COVID tweet rate, but education isn't anymore. Overall, this tells us that political affiliation and education level are relevant for predicting which counties will tweet misinformation about the coronavirus, whereas income is relevant for predicting which counties will tweet in general about the coronavirus, where wealthier counties will tend to tweet more overall.
To investigate our hypothesis on a potential correlation between COVID cases, vaccinations, and the number of misinformation tweets, we ran different types of regressions on the test set. We first ran a multiple regression where the target variable was the 7-day roll-in average of tweets in each US county and only considered data points with non-zero vaccinations. We also chose to only include cases and vaccinations and omit deaths because we found that cases and deaths had a strong positive correlation. This multiple regression showed a small but positive coefficient for cases, but the p-value indicates that this result is not significant. On the other hand, for vaccinations, we had a higher positive coefficient with a significant p-value, suggesting that vaccinations might positively impact number of misinformation tweets when accounting for cases. For the simple regressions, we found a positive and significant coefficient between cases and misinformation tweets. Up to this point, our findings were consistent with what we saw in the exploratory analysis on the training dataset. However, in the regression with cases versus vaccinations, there was a positive coefficient accompanied with a significant p-value. This result is counterintuitive and differs from our results on the trained dataset, where we found a negative and significant coefficient between cases and vaccinations. We suspect that this could be due to the small size of the test set and the fact that it only covers May and June 2021, which may not be reflective of general cases and vaccinations trends. It could also be related to other influencing factors that were omitted. This last unexpected result fails to prove that a causal model exists. Next, to see if the trends were only relative to misinformation tweets, we ran the same regressions on the unfiltered COVID tweets dataset. In the multiple regression, results were similar to the test and data, except that this time the coefficient for vaccinations was much smaller. This suggests a weaker positive correlation between vaccinations and unfiltered tweets when accounting for cases. In the simple regressions, cases and tweets also had a positive significant coefficient with a higher coefficient than before, but still showing the same trend. Finally, for vaccinations and cases, we had a negative coefficient with a significant p-value. This result is more in accordance with our hypothesis that the number of vaccinations negatively impacts the number of cases over time, and it is also more consistent with results from the misinformation training dataset.
To recap, we reject the null hypothesis that there's no relationship between misinformation tweet rate and voting pattern. We found significant positive correlation between Republican voting counties and tweet rate and negative correlation between Democratic voting counties and tweet rate, which is not mimicked in the unfiltered COVID-19 data. We couldn't reject the null hypothesis for mean retweet count. And other findings are that negative correlation exists between education level and misinformation tweet rate, whereas positive correlation exists between income and general tweet rate after accounting for education.
For our COVID-19 hypothesis, due to the surprising results between cases and vaccinations, we could not reject the null hypothesis that our causal model does not exist, but we did find significant relationships, namely that there is a significant positive correlation between vaccinations and the number of tweets when accounting for cases, but the coefficient is much smaller for unfiltered COVID data compared to misinformation data. There is also a significant positive correlation between cases and number of tweets for both unfiltered and misinformation tweets.
Some of the limitations of our work that we'd like to highlight are that geotags have limited accuracy. We had a limited number of tweets. Our methodology to filter misinformation is relatively naive, and we are missing demographic data for counties in US territories like Puerto Rico. For future work, we like to investigate a surprising trend we found related to per capita income. We saw that per capita income becomes much more important for predicting a county's misinformation tweet rate when accounting for education. Thank you so much for your time. Please feel free to ask questions. We are more than happy to answer them.